Today we're going to be learning about using composition to prove inverses. So we learned composition before and how to find an inverse, but now we're going to find out how to prove two functions are actually inverses of each other. So to prove two functions are inverses, I have to show that f of g of x equals x. That means I'm taking the g function, I'm plugging it into the f function, I'm going to simplify the problem down, and the only thing I should be left with is an x. And then I'm going to show that f of g of x is equal to x, meaning I'm going to now take the f function and plug it into the g function and show that once I simplify it, it all equals x. When I say x, I mean x, not x squared, not 2x, not negative x, just x. 1x is fine. And to prove it, you must show that both sides. Okay, so you have to do both to prove. All right, so here's an example. I have f of x is 3x plus 4, and g of x is x minus 4 over 3. And I say prove that they are inverses. So let's give them some colors. Let's do blue for f. Let's do red for g. And the first thing I'm going to do is I'm going to do f of g of x. So we are going to say this is 3 parenthesis x minus 4 over 3 plus 4. We're going to simplify. So the 3's are going to cancel, leaving you x minus 4 plus 4. Your 4's are then going to cancel, leaving me x, and that's good. I now have to do g of f of x. Okay, so now I'm going to do, this is 3x plus 4 minus 4 divided by 3. And notice, in each instance, that's where the x is. So just where that x is where I'm putting that function in. So here's the x up here, and it's just that x function that I'm making blue. We're going to combine these. 4's are going to cancel. 3x over 3. Then your 3's cancel, leaving me x. And yes, they both equal x. So yes, they are inverses. So now let's look at this one again. And again, we're going to see if 2x minus 1 and 1/2 x plus 1 are inverses. So the first thing I have to find is f of g of x. And again, let's, f will be blue, g will be my red. So this is 2 parenthesis 1/2 x plus 1 minus 1. Again, notice how just the x, this whole equation goes in just for the x. I'm going to then distribute. So 2 times 1/2 is going to be 1x. 2 times 1 is going to be plus 2 minus 1. This is 1x plus 1. This does not equal, and that's a 1 here. I don't want it to look like absolute value bars. This does not equal just x. Notice how there's still a plus 1. So because it is still a plus 1, no, they are not inverses. Okay? So again, we're going to try these again. And I have 3x squared plus 2 and the square root of x minus 2 over 3. We're going to make g red. And we're going to do f is blue. We're going to do f of g of x. And I'm doing this one because it's a squared and a square root. Just kind of want to show you how they work as well. And I have to do both of these, right? So let's do this. Let's plug g into f. So we have 3 parenthesis square root of x minus 2 times 3 quantity squared plus 2. And again, just the x. That squared goes on the very outside. You put a parenthesis and drop your equation in. So what's going to happen is I'm going to do the squared first. And I'm going to get 3 parenthesis x minus 2 over 3 plus 2. Because this square and that square root are going to cancel. Next, the 3's cancel, leaving me x minus 2 plus 2. And then these cancel, and I get just an x. So far, so good. Let's go the other way. Let's do f of g. So let's see. Let's start with this, and we get 3x squared plus 2. And let's build around it, minus 2 all over 3 under a square root. So right now, I'm going to work underneath this square root and just kind of simplify this right now. So the first thing I'm going to notice is these 2's cancel. So I'm going to have 3x squared over 3 square root of that. The 3's then cancel. I have the square root of x squared, and the square root of x squared is x. So yes, they are inverses. So if I ask you to prove, this is what I'm looking for. I'm looking for you to show me both f of g and g of f, and show me that both of them, yes, equal x. So try this one. Okay, so again, let's color code. F is going to be blue. G is going to be red. We have to do f of g of x and g of f of x. And let's plug it in. So let's go here. So this is going to be x squared minus 3 plus 3 and the whole square root of that. Looking at this, the 3's are going to cancel, leaving me square root of x squared. And that's x. So far, so good. Let's do it the other way. So this is going to be x plus 3. That's the f function. We're going to square it and subtract 3. All right. Let me look at this. What happens here? I'm going to end up with, this is x squared plus 6x plus 9 minus 3. Well, that's not going to equal. I'm sorry, it's not going to equal x. I'm going to get x squared plus 6x plus 6. And so no. No, these are not inverses. Okay, so look like they would have been, but they are not. Okay. All right, so let's redo this one. It doesn't seem like it took my voice. So let me get rid of some of this. All right, so we are looking at f of x, f of g of x. If we do this, it is x squared minus 7 square root of that plus 7. And we can stop right here because I cannot take the square root of x squared minus 7. Doesn't go away cleanly. The 7's are not going to cancel because this 7 is inside the radical. This one is outside of the radical. So you can tell me right off the bat that no, they are not inverses. If you guys need help with anything, you can join our Google Meets. Those links are on your schedule page when I have all the work written out for you. You can join me at ASA, which is from 2:30 to 3:30 on Mondays and Tuesdays. It's me. On Wednesdays and Thursdays, it's Mr. Parks. Either one of us can help you with any of this work. Or you can always email me. If you need anything, let me know. If not, have a great week, guys.